So in this video we're going to analytically or algebraically determine the domain of a function that has a square root function in its numerator and a quadratic in its denominator. So here's the graph of the function, and you can see it looks like the function doesn't have anything going on down here, and there's a hitch in its giddy up right around 3 it's looking like. And what we want to do is come up with the domain that kind of matches what's going on in the picture. We want to do it analytically, and what we're going to have to do is put together the previous 2 videos. We're going to need to put together what we learned in the previous 2 videos to take care of this particular function. So the idea is twofold. So we have 2 issues going on. One, we don't want to take the square root of a negative number. And this tells us that the stuff underneath the radical sign has to be non-negative. So step 1, we look at the square root and we say x minus 2, the stuff under the square root sign, has to be non-negative. And for it to be non-negative, it will need to be greater than or equal to 0. Any real number greater than or equal to 0 is a non-negative real number. So by not taking the square root of a negative, we won't wind up having to include the complex unit in our solution set. So if we solve this for x, we get x is greater than or equal to 0, or sorry, 2. Add 2 to both sides, and we get x is greater than or equal to 2. And then we have to deal with another issue. Because we have a ratio of a square root to a quadratic expression down in the denominator, we know that the denominator can't be 0. We cannot have a division by 0. So we need to take the expression, the quadratic expression in the denominator, the x squared minus 2x minus 3, and we need to identify that that denominator cannot be 0. And because it's a quadratic, I can solve this using the quadratic formula. I can solve it by completing the square. I can try to factor it and use the zero product property. And this one, it turns out, will factor nicely as x minus 3 times x plus 1. And we could always multiply this out to double check that work. So for this product to not be 0, we need x minus 3 to not be 0, and we need x plus 1 to not be 0. We need both of these to not, neither one of them get to be 0, which is why I get to connect this with an and. Now I add 3 to both sides. I see that x cannot be 3, and subtracting 1 from both sides on this guy, I get that x cannot be negative 1. So I need to use all 3 of these pieces of information to come up with the domain. The first thing I want to identify is that for x to be greater than or equal to 2, the output means the x's are starting here at 2, and to be greater than 2, the x's have to be going that way. That's what that tells me. So this restriction here that x can't be negative 1 really is embedded into the claim that x has to be greater than or equal to 2. Negative 1 is not greater than or equal to 2. So as long as we tell the reader that x has to be greater than or equal to 2, we've taken care of the fact that x cannot be negative 1. 3, however, is greater than 2. So 3 is a number that occurs to the right of 2. And you can see that at 3, the number that x can't be is where the function has this funky thing going on in it that, again, we'll look at much more carefully later on in the semester. So x not being equal to negative 1 is taken care of by x being greater than or equal to 2, but x being greater than or equal to 2 doesn't take care of the fact that x cannot be 3. So in interval notation, we need to say what x can be. So x is an element of. It's okay for x to begin at 2 and head towards infinity because x needs to be greater than 2. However, on the way to infinity, it's going to get to 3, and 3 cannot be used, so we use the open parentheses to exclude the 3, and then we say union, and it's okay to pick up at 3 and go off to infinity. So if I'm thinking from a number line perspective, what I'm really doing is saying start at 2, go to 3, And then those open parentheses right here are jumping over the 3, and from 3 we're heading off towards infinity, and that is the domain of this function that is a ratio of a square root expression to a quadratic expression.